This video is going to cover section 10.1, the parabola. All right, so in this section we're going to talk about what is a parabola, that's first, and then we're going to talk about what are some characteristics of the parabola, and then we're going to graph the parabola, and then finally we're going to use the parabola to solve some problems. So that's our approach in this video. We're going to begin with the definition. Now, a lot of us don't know the definition of a parabola. Actually, it's a lot more than we think it is. We're used to saying, oh, a parabola is y equals x squared. That's true. I mean, y equals x squared, the graph of y equals x squared is a parabola. And also we associate parabolas with quadratics. And again, that's also true. Parabolas are associated with quadratics. But what we need to develop in this class, in a pre-calculus class, is an understanding of what exactly a parabola is. So I can turn on some lights there so we can see a little better. Sorry about that. So, what is the parabola? Here's the definition, okay? It starts with a parabola is a collection of points. Now, that I hope goes without saying, right? We need a lot of points to make a parabola. So a parabola is a collection of all points, P, in a plane. And that's the part that a lot of us overlook, right? We forget that we're talking about something here that's in a plane. Now, what are the important characteristics of these points? Well, as it turns out, these points share a distance-based definition. That's what's important. So a parabola is a collection of all points P in a plane that are the same distance. Okay. So all these points share a characteristic. It's a distance-based characteristics. They're all the same distance, and we're going to name that distance d. All right, that's probably not the most original, but we're going to call it d. From a fixed point, all right, some point that's fixed. Since it's a fixed point, we're going to call that f, us mathematicians in our imagination. As they are from a fixed line which we're going to call D. Now, these letters D and F, we pick these for the following reason. Right? Those are there because they're the first letters in the name of this fixed point and the first letter in the name of this fixed line. So the fixed point is called the focus. And the fixed line is called the directrix. That's misspelled. Forgot an E. Now, many of us may or may not have ever seen this definition before. This is the pre-calculus definition of a parabola. So what is it telling us? It says, well, it says this. Let's just take our friend y equals x squared, right? The parabola that we all think of as the basic parabola or the classic parabola. What do we know about this parabola? Well, we know it goes through 0, 0. We know it goes through 1, 1. We know it goes through negative 1, 1. And then the next point it goes through is 2, 4, right? 2, 4. That's here. And negative 2, 4 is here. These are the points that we think of as being the important points, right, of our friend the basic parabola. Now, what does this definition say? Well, you'll notice that the definition doesn't even talk about the vertex. The vertex, one of the things that we find to be the most important, we're in an Algebra 2 class, right? Because when we're in an Algebra 2 class, we write a parabola as y equals a times x minus h quantity squared plus k, and we say the vertex is hk, right? Our Algebra 2 approach was all about the vertex and A. Well, our approach in pre-calc is not about the vertex and it's not about A. It's about the focus and the directrix. That's what it's about. It says that this parabola has a point, which we're going to call the focus. And that point is special because it says, all right, if this is a point on my parabola, I'm going to have some line, right? We'll just draw a line. We'll see how we do it. Here's a line. We'll just say there's our line D. That's the directrix. Okay, that's D. And we'll pick this distance, right? We'll start with the vertex. This distance, it says a parabola is a collection of all points in a plane that are the same distance. The same distance. So whatever this distance here is, I am away from the directrix. I have to be that distance away from the focus. So if I do that, right, if I take this and I transform it here, we would be arguing that this is the focus. Now, if that really is the focus and that really is the directrix, then what does our definition say? Our definition says if we just pick a point, any point, right, it's a collection of all points, so we pick any point, like this one, right, it's just a random point. The distance from my focus to my point is supposed to be the same as the distance from my point to my directrix. Well, those are clearly not the same distances. This is way too small to be the same distance as this. Now, what does that tell me? That tells me this point here, F, right, this guess, quote unquote, at my focus, and this quote-unquote guess at my directrix, those were not very well thought out guesses. Those were not guesses that led me to the correct focus and the correct directrix. So what we're going to need is something more than a guess, right? We're going to need something more than a guess. We're going to need a formula, a plan, some strategy to be able to find our focus and to be able to find our directrix, because in pre-calculus, those are the important characteristics of a parabola. Yes, we're going to still pay attention to the vertex, and we're still going to do the things we did back in Algebra 2 with A. Remember what we said back in Algebra 2? We said if A is greater than 0, it opens up. We said if A is less than 0, it opens down. Right? That's what we said. And we said if the absolute value of A is greater than 1, right? If the absolute value of A is greater than 1, then we said, well, we said there's a difference between a parabola where the absolute value of a is greater than 1 and an absolute value of a is less than 1. Here we said the parabola was narrow, and here we said the parabola was wide. Okay. So those were the characteristics, and that was our approach in Algebra 2 to parabolas. But in pre-calc, we're going to change that approach. We're now going to pay attention to a point called the focus and a line called the directories. And we'll see why those are important to us as we move through this lecture. All right? So I'm going to erase this, and we're going to start with what do we know, how do we know it, and how are we going to get to these two new ideas, this directrix and this focus. I should have left this part out there, huh? In case we jump into the middle here. So, what are we going to do and how are we going to get there? Right? Where is all of this going to come from? Well, we're going to start with a theorem. And this theorem is the equation of a parabola. Now, it's not just any parabola. It's the parabola that has a vertex at 0, 0, and has a focus at a 0, where a is greater than 0. Now, what does that mean, right? Well, if we think about this, the vertex is going to be at the origin, and the focus is going to be at A0. Y is going to be 0. Y is going to be 0. If we draw a quick sketch and we think about what a point like that looks like, that would be like something like the point 1, 0. That's right here. That's going to be our focus. Our vertex is going to be here, which means our parabola is going to open to the side. Now, in Algebra 2, we started with everything was based on a parabola that opened up and down. Here, we're changing that. We're opening the parabola to the right. Our basic parabola in pre-calc is going to be the one that opens to the right, not the one that opens left. So that's going to take a little bit for us to get used to, a little bit of time for us to get used to. So how does this theorem say, right? Well, remember, this is just the title of the theorem. It tells us the equation of a parabola, vertex is 0, 0, focus at A0. Here's what it says. It says the equation, because that's what we want, right? The equation, because that's what we're ultimately going to be asked for all the homework on, is find the equation of the parabola. So the equation of a parabola with vertex 0, 0, focus A0, and directrix Now, we know the directrix based on this information because our definition, remember what our definition said? Our definition said every point on the parabola has to be equidistant between the focus and the directrix. Every point. In particular, let's think about the origin, right? I know this is a little sketch, but let's just use it instead of making it bigger. Let's think about the origin here. What do we know about the origin? We know the distance between the origin and the focus has to be the same as the distance between the directrix and the focus. So the directrix has to go through this point right here. So our directrix is going to look like this. So we have the same distances. So if our focus is at A0, that distance is going to be A units. So this distance needs to be A units. Well, if I go A units to the right from 0, I land at A. If I go A units to the left from 0, I land at negative A. So my directrix is going to be x equals negative A. Remember, we said A is a positive number. So let's reread what we've got written so far in our notes. The equation of a parabola with a vertex of 0, 0, a focus of A0, and a directrix of x equals negative A is what is the equation? Well, the equation is y squared equals 4ax. Okay? That's our basic parabola in pre-calc. I realize that does not look like your basic parabola from back in Algebra 2, because back in Algebra 2, your parabola opened up. Our parabola opens to the right. Okay? And this parabola is based on our decision to pay attention to the vertex and the focus. Okay? So we are going to be working in section 10.1 from the perspective, here's the focus, here's the directrix. Go find me the vertex. And so we're changing the direction that we're approaching parabolas from this section. So we have to become comfortable with that. So this is our parabola. This parabola opens to the right. And it has a vertex of 0, 0. Okay? So that's what we have as our basic parabola. Now, what will we do with that? We'll do problems, right? We'll work on homework problems, and let's do an example right now. Find the equation. Here's our example, right? Because we know where this is going to go. They're going to want us to find the equation of a parabola. So let's say we want to find the equation of a parabola with vertex 0, 0, right? And a focus of, let's say, 4, 0. Because that's all we know. We don't know how to find the equation of a parabola if we move the focus off the x-axis. That's all we can do. So what you and I can do to begin this, right, to begin this, is we can draw a sketch, because a sketch helps. So if we draw a sketch, we'll come over here, and here's our x and our y-axis. What do we know about our parabola? Well, we know where our parabola is located. We know our parabola has a vertex at the origin. Right? Now remember, the focus is always inside the parabola. We're going to learn something about the focus here just in a second, but the focus is always located inside the parabola. So what do we have? We have a focus at 4. 4, so this is our vertex, and this is our focus. And when we draw parabolas in pre-calc, this is what our graph usually looks like. Usually we have some focus, we label that F, and then when we tell people, well, that's 4, 0. And then we have a vertex, and we know that's going to be 0, 0. Okay? Now, where's our directrix? Remember, the directrix is a fixed line that every point on the parabola has to be the same distance between the focus and the directrix. And we have in our theorem right here, it tells us our directrix is x equals negative a. So our directrix, right, our directrix is going to be over here at negative 4. So here is our directrix right here. Now, what do we need, right? Well, we need a better drawing. Let's see how we did here. Yeah, that directrix is way off. So let's move that directrix so that we we have a better drawing, okay? So I'm going to clean this up a little bit. Now, what do we know about a point on our parabola? Well, a point on our parabola is supposed to be the same distance from our directrix, x equals -4, as it is from our focus. So we could ask ourselves, for example, is the point 1, 1, right? Is the point 1, 1 on our parabola? Well, if it is, that would mean this distance right here would have to be the same as this distance right here. And we can see pretty quickly that those two distances are not the same. So 1, 1 is not on our parabola. Now that's not how we're going to approach this. We're not going to sit around and guess to see if points are on the parabola. What we're going to do is we're going to write the equation of the parabola, because that's what we're asked to do here, find the equation of the parabola. And we have a formula for that, right? We know, because we drew our sketch, we know our parabola goes like this, right? We know our parabola goes out like this. And if it opens to the right, this is our formula for the parabola that opens to the right. So all we have to do is know A. If I know A, I'm done. And I do know A. A is the distance from my focus to the vertex. That's A. In our problem, that's going to be A equals 4, because we know how far. The focus is at 4, 0, the vertex is at 0, 0, that distance is going to be 4. A is also, by the way, the distance between the directrix and the vertex. So A equals 4. Where do you want to find it? Do you want to use the focus, or do you want to use the directrix? Whichever you have, use that. Of course, if you have one, you can figure out the other one, because you know those two distances are the same. So what's the equation of our parabola? Well, for us, A is 4. So because it opens to the right, this is the formula we use for opens to the right. So our equation is going to be y squared equals, the formula has a 4, we'll put that in there. Our A is 4, we'll put that in there. And then we have x. And so we get y squared equals 16x. That's the formula for our parabola. And now we can see that 1, 1 certainly is not on our parabola, is it? Because we were thinking maybe 1, 1 was on our parabola. Hopefully that's not one of you sending me a text. So, this is our parabola, y squared equals 16x. And what do we know about our parabola? Well, we know 1, 1's on our parabola. If we put a 1 in here, we get 16 times 1. 1 squared is 1. 16 doesn't equal 1. So we know that's not a point on our parabola. So, right now, we're asked to find our equation. Now, if they want us to graph the parabola, what are we going to do? Well, if we're going to graph the parabola, right, if we're going to graph the parabola, how are we going to find points on the parabola? Well, you and I are going to talk about a set of 2 points right now that are really important. And if we would continue drawing this parabola, if we continue drawing this parabola, it would look something like this. It would be really wide. It goes out like this. This is our parabola. Now, there is a characteristic to these parabolas. You may have talked about in Algebra 2, you may not have talked about in Algebra 2, I'm not sure. And that is the line that goes through the focus, parallel to the directrix. This line has a name. This line has special characteristics. We want to know about this line. So first we'll start with its name. We call it the latus rectum. Right? The latus rectum. And we know something about this line. Okay? First of all, again, to review its characteristics, it goes through the focus, it's parallel to the directrix. And we know the length of this line, right? The length of this line is 4a. So let's write that down. The length of the lattice rectum is 4a. Now, why is that important? Well, that means this width right here is 2a. It's half of the total length. And this width, or this length right here, is 2a. It's half of the total length. Well, if we know that, we can find these points. That gives us an automatic go-to move to find 2 points on our parabola. Without having to plug in x and solve for y, we can just write down 2 points. Look at our picture. We went over a, up 2a. So in general, this point, write this in your notes, this point is a, 2a, and this point right here, we went over a, we went down 2a. So those are 2 points that we know on every parabola. And we can find those points, right? What's the length of our lattice rectum? We'll switch back to red since we're solving our problem in red. So the length of our lattice rectum equals what? It's 4a. That's the formula, so it's 4. Our a was 4 as well, so we got 16, right? So what are 2 points on our parabola? Well, 2 points in our parabola are going to be these 2 points where the lattice rectum intersects the parabola. That's my dog, by the way, in case you're wondering what that is. He's stretching. So what do we have here? We have this point. Well, in our problem, a was 4. A was 4. So that's going to be the point 4, right? Comma. And then we go up 2 times a. A is 4. 2 times a is 8. So that's 8. And we know the other point, right? The other point is a. A was 4 for us. And then negative 2 times that is negative 8. So these points are on our parabola. They're automatic, they're easy to find, and most of the time when we ask you to graph a parabola, we want you to label 2 points. And now you have a way to label 2 points without having to do too much work. You just use the lattice rectum. Now, let's check. Let's check and see if this works, right? We're claiming 4, 8 is on our parabola. Let's plug in x is 4. X is 4. 16 times 4 is 64. 8 squared, 64. It works. It works. So one thing that we're going to do in the homework is we're going to be asked to find the equation of a parabola. And then they're going to ask us questions about the parabola, right? When we're done, they're ultimately going to ask us to draw the graph. We always ask you to draw the graph. So when you're asked to draw the graph, you now have a way to find 2 points. Don't forget to write this down. We often don't see students who spend enough time learning about the lattice rectum of the parabola, and then they have to work harder to find the points on the parabola than they should. All right, so let's look at another example. Okay, so what else could they possibly ask us to do here in this section? Well, right now we're still only focusing on parabolas that open to the right. We haven't learned how to handle any other parabolas. We're going to do that. Don't panic. We're going to learn how to handle parabolas that open up, parabolas that open left, parabolas that open down. But what else could they ask us to do in the homework? Well, another question they could give us, right? Another question they could give us is they could give us a parabola, like say they give us y squared equals 8x. They give us the equation. Instead of us finding the equation, we're given the equation. And they ask us the normal questions, right? What are the normal questions? Well, the normal questions are what's the vertex, right? What's the vertex? They're going to ask us what's the focus now. They're going to ask us that question. They're going to ask us where's the directrix, right? That's going to be a question we get. And then they're going to want the graph. Now, how are we going to do those four things based on that equation? Well, we're going to look at the equation, and each and every one of us are going to learn these equations. We're going to learn from inspection, because we're going to write them down on our notes just in a second. We're going to learn, hey, this one opens to the right. I know it opens to the right because it's y squared equals 4ax. That's who this is, right? This is y squared equals 4ax. We have to recognize that. Now, it's not always going to be the case. It is the case in this problem, because it's an example and we're just starting. This divides by 4. So that's really nice, but it doesn't have to be a factor of 4. So what does this problem transform itself into? We want to make it look like this. We need a 4. Our formula says I have to have a 4. So I'm going to rewrite this. I'm going to rewrite this as y squared equals, I need a 4. And then what's 8? 8 is 4 times 2. So I'm going to have 2. And then I'm going to have my x. And because I've written it in this form right here, I now know a equals 2. Plus, because it's written in this form, it's written in that y squared equals 4ax form, we already know, because we've learned this in our theorem, we learned our vertex is 0, 0. Right? There's no h and there's no k in there, so our vertex is 0, 0. So we're on our way to being able to do everything we've been asked to do here in purple. We know the vertex. We can find the focus, right? Now what I like to do is I like to do this by drawing a sketch. I think visually it helps me find these points if I draw the sketch first. So because this is of the form y squared equals 4ax, I know by my theorem that my vertex is at the origin. I also know my focus, right? We were taught that, our theorem taught us, our focus is A0. So we know where our focus is. Our focus is right here, so we can label that F. We can label that our focus. So in answer to these kinds of questions, which is what we're going to get on the test and the quiz, we can start filling things in. We can say, well, the vertex, right? Pretend this is our answer blank. We would write 0, 0 there. Focus, right? For focus, we would write 2, 0 there because we know A is 2. We could figure that out by dividing a 4 into this, and what we were left with was 2. So we've got our focus. We've begun to draw our graph. We have to know where our directrix is. Now remember, our directrix is the same distance away from the vertex as the focus. So our directrix is over here. This is our directrix. Now we have to write that down. Well, we all passed Algebra 1. We know a vertical line is x equals, and since that's the point 2, 0, right? Since that's the point 2, 0, we know this is x equals -2. That's in our theorem. So our directrix, remember, our directrix is a line. So we want to write that as the equation of the line. We don't want to just write -2. That's not a line, that's a number. So we get x equals -2. Now, the only thing left for us to do is draw the graph. Well, we've got the graph pretty much figured out. All we have to do is fill it in. Right? We've got the focus here. We've got the directrix here, and we just have to draw our graph so that we, right? Now, if you're confused about how wide to make the graph, which most of us would be if we don't have a lot of experience with this, maybe a better idea rather than starting to write the graph, right? That's confusing. Why don't we label 2 points on the graph, and then we can draw it. And we know where 2 points live. We know, because we took good notes on the previous example, we know that somewhere on this line, there are 2 points that lie on our parabola. Our parabola is going to come around here and come around here. It's going to intersect this line. How and where it's going to intersect the line, right? That's another story. But it's not a hard story. We know that we're going to look at the latus rectum. And what do we know about the latus rectum? We know its length, right? We just wrote this in our notes. The length is 4 times a. So the length of our lattice rectum is 4 times a. For our problem, that's going to be 4 times 2. That's going to be 8. Now remember, that's the length of the entire lattice rectum. The entire lattice rectum is 8 units long. So the distance from the x-axis up is going to be half of that. That's going to be 4. So we're going to go 1, 2, 3, 4. And we're going to say, okay, that point's on our parabola. And then we're going to go down 1, 2, 3, 4. And we're going to say, okay, that point's on our parabola. Now we know what those points are. We know we took half of this, right? Half of this. Remember, the entire length is 4a, which means this piece, this half, is going to be half of 4a. That half is going to be 2. And this piece right here is also going to be 2a. Now, because we found a way back here, we know what those points are. Right? We know this is A, right? We wrote that in our notes. Let's rewrite it here. This is A. So we went over 2, up 2 times A, which is 4. So this is the point 2, 4. And this is the point 2, negative 4. And now we can simply draw our parabola. See how much easier that is once we focus, pardon the pun, once we pay attention to the lattice rectum. And if we're confused and if we don't think we drew the graph correctly, we can check. We have a point right here, 2, 4. Let's put in x is 2. X is 2. 2 times 8, 16. Y is 4. 4 squared, 16. It works. So from here, apparently my cat would like to be fed, but we're not going to stop to feed the cat. From here, we're going to write down the equations of our parabolas. Just like we did back in Algebra 2. We're going to write the equations of our parabolas. Okay? So, we're going to make a table. Okay? We're going to make a table, and we need to get this into our notes, because this is highly important. This is how we're going to solve all the problems. Okay? So here's what we know. We're going to talk about where is the vertex. We're going to put the vertex down first. And then we're going to talk about where is the focus. And then we're going to talk about where is the directrix. And then we're going to talk about the equation. Okay. Now we're going to use this table twice. We're going to write it down 2 times. We're going to start with the case where the where the vertex is 0, 0. Our focus is A0. This is our theorem. In case this looks familiar, this is the theorem we wrote down. Our directrix, of course, in that case was x equals negative a. And we said our equation is y squared equals 4ax. Now, I didn't make a big deal out of this until now, because now is when I wanted to bring it up. In Algebra 2, we didn't solve for the square, did we? Let's write that down right over here in pen, just off to the side. In Algebra 2, we wrote things like y equals 2 times x minus 3 squared plus 4. Do you see in Algebra 2, we solved for the variable that had a power of 1. But in pre-calc, we're solving for the variable that has a power of 2. So we're taking the approach we had, and we're kind of looking at it from the other side. We're not undoing it. We're not doing that. That would mean we're taking the inverse of this. But we're just looking at it from a different perspective. Instead of solving for the variable that has a power of 1, we're solving for the variable that has a power of 2. That's why it looks so different to us. Now, what else? We all know this opens right. We'll write that right here. Opens right. What would make this open left? Right? The same thing that made it open left back in algebra 2. If we kept the vertex here, right? But instead of wanting it to open right, we want it to open left. Well, let's work backwards. In algebra 2, we said if we wanted to change directions, we have to put a negative in, and that's exactly what we're going to do now. It's not going to change. We're going to get y squared equals negative 4ax. If we have a negative, it's going to open left, just like it did in algebra 2. But if it opens to the left, let's draw a quick sketch over here. Right? If our parabola opens to the left, isn't the case that our focus is going to be, it's got to be inside, our focus is going to be over here. So instead of our focus being A0, our focus is, yeah, you're right, our focus is going to be negative A0. And now our directrix is going to be over here. So instead of our directrix being x equals negative A, our directrix is going to be x equals positive. Now what about up and down? Right? How is up and down different from right and left? Well, back in algebra 2, up and down, right, up and down, we had this person, y equals x squared. This was our basic problem. It opens up. Well, now we focus on x squared, don't we? We focus on x squared. So if we wanted to open up instead of to the left, our vertex is still going to be 0, 0. All right? So let's erase this with this little sketch we've got here. Let's make it open up, which is what a lot of us have wanted to happen since we started this. If our parabola opens up, our focus is going to be up here, isn't it? Because our focus has to be inside the parabola. So that's not A0. The x-coordinate of that point is 0. The y-coordinate is A. So to make it open up, we just reverse the roles. So instead of our focus being A0, our focus turns out to be 0A. And all of you would have figured that out without this lesson. You would have just drawn a picture and you went, well, that makes sense. Now the directrix is down here. Well, that's a horizontal line. So instead of x equals A, that's going to be y equals A. They're just parabolas. They're not supposed to be complicated. What is our formula? Well, we're going to switch. We switched x and y everywhere else. So over here, we're going to have x squared equals 4ay. And I think you can do that. I'll write it on our table so our notes are complete, but I'm willing to bet a large amount of money that right now all of you can write down. So this one opens up. All right, we'll add that, opens up. Correct, I kind of got the right table. Now, what about opens down? Well, that's going to be 0, 0, isn't it? If it's going to open down instead of open up, our focus is going to be down here now. So instead of our focus being 0A, our focus is going to be 0, negative A. And our directrix, of course, is going to move up here. And so instead of our directrix being y equals, wow, that was, sorry about that. All of you that were yelling at me in the video, I didn't see that, but you're right. That was supposed to be y equals negative A down here, wasn't it? So this one's going to be y equals positive A. Right? We're going to put a big red circle around that just to make sure everybody pays attention and changes their notes. You know, I got that wrong, so we want to put a big red circle around it so we can see that it's corrected now. And what's our formula going to be for opens down? X squared equals negative 4ay. That's exactly correct. Now, this is really important, right? Because when they give us an equation, we need to know that one opens up, that one opens down, that one opens left, that one opens right. Otherwise, we're just guessing which of the four. Now, from here, right? From here, we're gonna, oh, we should complete our table here. We should write opens down. From here, we're going to go to the general case. What happens? What happens if our vertex moves off the origin? Now, don't panic. It's not going to be hard. We all know what's going to happen here. I'm going to erase this. And I'm just going to draw a quick sketch. And just pay attention to the sketch. It's all going to make sense. What happens if we move the vertex? Right? Say we go here H, and we go here K. Now our first case is opens right. Opens right. So one way we can do this, right? One way we can do this is we can cheat. We can draw a set of axes that look like this. And we can think to ourselves, okay, if it opens right, so now it opens right, let's draw it in blue. It opens right, so it goes like this. Okay, well, we all know where the focus is going to be, right? The focus is going to be right here. Now we have to write down those coordinates, right? That's what we have to do. We've got to write those coordinates down. What are the coordinates of that point? Well, they're not A0 anymore. Oh, this distance right here is still A. I agree, that's still A. The focus is still A units away from the vertex. But that point isn't A0 anymore, is it? What point is that? Well, let's just fill it in. What's its y value? Right? What's the y value of this? Well, we went up k units. So the y value is going to be k. Right? We went up k. What's the x value going to be? Well, we went this far, h, and then we went this far, a. So isn't this just going to be h plus a? So if we're looking for the focus, and we're doing this case, but now we've moved the vertex, look what's going to happen. Our focus is now going to be h plus a k. All right? Now there's going to be a pattern here that's going to help us keep things straight. Now where is our directrix going to be? Well, our directrix is going to be this many units from the vertex, right? So our directrix is going to be right here, right? This distance has to be the same as this distance. Now remember, that's A. That's A. So we have to figure out what is this value right here, right? Where is our directrix? Well, where are we located? Well, we started over here at H, right? We started at H, and we backed up A. We backed up at A. So what does that look like? Well, I started at H, and I went left A. When I start at a number and I move to the left, I subtract. So my directrix is going to be x equals, right, because it's a vertical line, x equals h minus a. Now if we take a look up here, look at this. All we've done is added h and added k. And all we did here was add h. Look, we just added an h. Instead of it being negative a, it's h, take away a. We just added h plus h. What is our equation going to look like? Well, I think if you try, you can probably figure out what it's going to look like. It's going to be y minus k squared equals 4a times x minus h. Just like it was back in Algebra 2, we're going to put the minus h minus k. The h is the x, right? The h is the x, so it's going to be x minus h. The k is the y, so it's going to be y minus k. That's going to be our equation. So this one opens right. Now, we're going to write down the other ones. What happens if we want to open left? Well, you can see right here, there's going to be a negative a here, so this is going to be h instead of plus a, it's going to be minus a, okay? There's a positive here, so that's going to be x equals h plus a. That's why I said learning this set right here was so important because it helps us write down this set. Now, we know we want to open left, so we're going to have to put a minus sign, right? A minus sign. So this is going to be y minus k squared equals negative 4a x minus h. Now, how about opening up? Well, we're going to have our vertex at hk. Now, the h gets added here, right? The h gets added here, so we're going to have h plus 0, that's just going to be h. We're going to add the k there, so we get k plus a. Over here, right, we have y equals now, right? Y equals. And we're working on y, so that's going to be k, so this is going to be k minus a. Now we want it to open up. If it opens up, x is going to be squared, right? We learned that in Algebra 1. X is going to be squared. So this is going to be x minus h squared equals 4a y minus k. And then our last one. It's going to be h, right? We have a minus a, so this is going to be k minus a. This is an a, so this is going to be y equals k plus a, because it's positive a there. And now it opens up, so we need to square the x, so we get, not there, Kevin. We get x minus h squared equals, oh, I'm sorry, we're doing, this one was opens up, huh? That's why I misspoke. This one is opens down. So this is going to be minus 4a y minus k. Now, these look confusing, but after you do the homework, you're going to fall into a much more comfortable state with these formulas than you are right now. Right now, we're just writing them down for the first time. They seem a little different. They seem a little unique. They're not exactly the formulas we learned in Algebra 1, but these formulas allow us to pay attention to the focus and the direct arrows. All right? So let's take a look at a problem. What is a homework problem going to look like? And then we'll close out this video. So unfortunately, right, I'm going to have to erase this. Now you have it in your notes, so you're not going to be without it. You'll have it sitting there in your notes. You can take a look at it as we do a problem. So what's a typical homework problem going to look like? All right? What's a homework question going to look like? Now this is my lecture video. I'll do some problem solving. I'll do a problem solving video on chapter 10, section 1 as well in the next video. But right now we'll do one example. We'll close the video out, and then I'll do in the problem solving video. I'll do some more examples. So what are we going to see here? What are they going to give us, right? There's, excuse me. They're going to give us, right, problems that look like this. Maybe they'll give us something like, I'll just pick something that looks not fun. Let's do that, okay? So where can we go? Well, they can give us a problem that looks like this. X plus 4 squared equals 16 times y plus 2. Right? Now this problem's actually from the book. It's problem number 42 in the textbook. All right? And what do they want us to do? It says find the vertex, so we'll write our little answer blank over here. We want the vertex, we want the focus, we want the directrix. I had a tough time spelling that one today. And we want to draw the graph. All right, we'll write graph. but we're not going to obviously fill it in over here. We'll do the graph over here. Now, if we take a look at this problem, it's already solved for us. I mean, everything's there. We can see everything we need. The first thing you and I have to do is we've got to figure out which way this opens. Now, this has an x squared. We said if there's an x squared, that's up or down. Right? That's what we have. When x squared, just like algebra 1, just like algebra 2, since the x is squared, this opens, right? And our choices are up or down. Because the x is squared, it's going to open up or down. Now, what do? We look across here, we see a plus, and we know ours opens up. So right now, we can start with the graph, right? Because that's where this problem is going to end up. Now, before I can draw the graph, I need to find the vertex. Well, I know that this is h, it's next to the x, so this is h, and this is k. Right? But remember, the formula comes with a minus sign, and it doesn't. The formula says x minus somebody squared equals 16 times y minus somebody. That's what the formula says. The formula brings with it an inherent negative sign. The negative is built into the formula. So how did I get the positive 4 then? You're correct. We have a negative 4. And how did I get the positive 2? We have a negative 2. So our vertex is going to be negative 4, negative 2. X, negative 4, y, negative 2. So our vertex is over here 4 and down 2. Now, which way do we say our parabola opens? Yeah, we said it opens up. So what do we know, right? Well, we haven't talked about it in this video, but there is something that we remember from Algebra 1 and Algebra 2. We do know that parabolas have a line of symmetry, right? We haven't brought it up yet, but I'll bring it up now. There is going to be a line of symmetry on this parabola. It's going to go down like this. This is going to be my line of symmetry. I know my focus has to be on this line of symmetry. I know that. And how far is my focus from the vertex? Do you remember? That's A, isn't it? Well, what do we have here? We have something very close to our general formula, but it's not exactly our general formula, isn't it? Right now, we've changed this. We've written it as x minus, we put a minus formula. Now, you don't have to do that in your homework. You can do that in your head. I'm just teaching, so I'm trying to get it all included. Now, we're supposed to have a 4 out here. The formula came with a 4. Now, we have a 16. It's supposed to be 4 times A. That right there is 4 times A. We can go over here and go, hey, 16 is 4 times A. A is 4. A is 4. So that goes here, right? Because that's where our A went. And then we have y minus 2. So for our problem, A is 4. Now, what does that mean? That means we can find the focus. We move from the vertex. We're opening up. So we go up 1, 2, 3, 4. So here's our focus right there. Now we want to label that. So what point is that? That's negative 4, 2. Now where's our directrix? It's the same distance down from the vertex, isn't it? So we go down 1, 2, 3, 4, right? Because remember, we found A to be 4, so this right here is A. And this right here is A. Now, where are we now? Now, we haven't drawn the directrix yet. We have to draw it. We have to draw it. The graph, and when they ask us to draw the graph, they're going to expect us to have the directrix drawn there. So when we draw the directrix, we notice something. We notice, hey, you know what? It's perpendicular to the line symmetry. Now, this is y equals, yes, because it's a horizontal line. And where are we? Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Right? Because we're right here. Remember where we are. Negative 4, negative 2. And then we went down 4. So we get y equals negative 6 as our directrix. Now, to draw our graph, we need 2 points. Right? We need 2 points. And we know where to go to find those 2 points. We know the easiest place to go to find those 2 points is the lattice rectum. We draw a line through the focus parallel to the directrix, and we know how to find 2 points on the parabola. We know that this distance right here, right? Because how long was the lattice rectum again? Go back and look at your notes. How long was the lattice rectum? It's in the book. I'm flipping through the book here. It's on page 634. It says the lattice rectum is 4a long, which means this half is 2a, right? And this half over here is 2a. Now this is not the scale, because we can all see that 2a is 8, isn't it? 2a is 8. Now 8 from here, right, we're at -4. 8 is going to be at +4, isn't it? Now we know what that point is. That point, we moved over 2a. Here, I'll go ahead and draw this one to scale. I can't draw that one to scale because it goes off the video. So we'll draw that one to scale. That's 2 times 8. That's going to be 8. We're at -4. We move 8. So we end up at +4, 2. So that point is on our parabola. So our parabola goes through here and through there. Now on the other side, we could figure out that point as well, couldn't we? We know what that point is. It's not -4, 2. That's not right, because we moved 8 from -4. We have to start at -4 and move 8 the other way, right? If we start there, -4, move 8 the other way, that point would be -12, right? -12, +2. And so we've got our graph. All right, I'll solve more problems on the 10.1 homework solutions video, but this will get you started on section 10.1.